In this lecture, we're going to learn about the sort algorithm. This is an algorithm we can use to sort data in our collection, and I don't think there is more one can say about this. Let's look at a simple example. So we have a collection here, which is an STD vector. The data is not ordered in any way, but if we use our sorting algorithm, passing the beginning and end iterator, this is going to sort the data we have in this collection, and if we print it again, we're going to see that the data is going to be ordered. Now, if we come to the documentation, we're going to see that this algorithm requires a random iterator to work. So if you pass in anything that doesn't offer random iterators, that's not going to work. And I have seen many students try to use containers like stdlist with our sorting algorithm, and they were surprised to see that there are a bunch of compiler errors. Now, I would invite you to read the type requirements section on each of these algorithms, and you're going to know the things that are required for the algorithm to work. If you look here, you're going to see that one of these things is that the iterators to the container have to be random access iterators. And we know that, for example, stdlist doesn't find a random access iterator. And if you try to use that with our sorting algorithm, things are going to blow up and you're going to have a bunch of weird compiler errors. You should know this. It is also possible to specify a predicate that the compiler is going to use to decide which element comes in front of another, and that can come in the form of either a function pointer, a functor, or even a lambda function. Here we have an example using a built-in functor, we have another built-in functor, we have a lambda function. All these things are going to work, and data is going to be ordered in whatever order is specified by the predicate that we pass here. And we're going to see that if we print our data as we see on this line. Here is another example showing us that we can sort collections containing custom items. This is just another example to show you how you can work with these things. So we can sort exactly like we did in previous slides, specifying a predicate as we do right here, or we can even leave this predicate out and stdless is going to be used by default. At least I think it is even possible to specify a lambda function as we do here, and this is going to be picked up and used in this line here. And if we print our collection, we're going to see the data in whatever order is specified by our sorting algorithm, and this is going to work really well. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. And before we go, I want to correct this small typo that I have here. This is going to look for the less than operator in whatever type we are storing in our collection, and it is going to be used to order our elements through the sorting algorithm here. Let's head over to Visual Studio Code and play with us. Here we are in our working folder. The current project is sort. We're going to see how we can use our sorting algorithms. So let's grab our template files and get started. We're going to put them in place. And we are going to crack this open in Visual Studio Code. This is going to give us our main CPP file that we can clean up a little bit and remove what we don't need. And we will close the sidebar here. Let's bring in the headers we need. We need algorithm for sure. And we need vector. We also need to put in our book class, which is what we're going to be storing as custom types in our collection. This class is going to have a less than operator that we're going to use to order elements. So we need this operator in place. And we also have a greater than operator, which I think may be used by the std greater functor that we can pass as a predicate. But I think the compiler should have the ability to deduce that using the less than operator. But we're going to see how this works out. So we also have a print collection function, which is going to print our collections. So we can go down and set up code that uses these things. We're going to set up a collection, which is going to be a vector here. We're going to print it out unsorted. We're going to sort it using our sorting algorithm. You see that we pass in a beginning iterator and end iterator. We don't need to specify a predicate here because stdless is going to be used by default by our sorting algorithm. And if we print the collection again, we're going to see that the data is going to be sorted out already. Let's pass this through the compiler. We can use GCC for that. The build is good as you see, and if we clear, let's not clear yet. We need to bring up a terminal window and then clear. And if we run Rooster, we're going to see that the first printout is not going to be sorting our data, but the next time we print using this statement here, the data is going to be sorted by our sorting algorithm. Now, earlier I have said that this algorithm requires random access iterators to work, and that's something we have seen in the documentation. So if we change this to use std list, for example, let's bring in our list container. We know that std list doesn't support random access iterators because of how it is set up. So we aren't really going to get this to work if we use std list here. Okay, we have changed this to std list. Let's pass this through the compiler and see what we get. And the build is going to fail with a random compiler error. That is really hard to understand for many people. Let's go up and see if we find anything useful to look at here, because all this gibberish is not going to make any sense, and we don't have anything we can really look at. But the problem is that we are trying to use the sorting algorithm with a container that doesn't have random access iterators. Okay, let's turn this back to std vector now that you know these kinds of problems. And we are going to set up an example that is going to use a predicate, and the predicate is going to decide which element is less than another element, and elements are going to be ordered in ascending order if we specify the less predicate here, which is a standard functor in C++. So if we try and print again, we're going to see that data is going to be ordered, so we can pass this through our compiler. The build is going to be good. We can clear and run Rooster. We will see our data ordered in this second set of statements here, and this is really cool. We can change our predicate to be std greater, so let's do that. And if we build, we're going to see that the build is going to be good, and the data is going to be ordered in descending order. We can clear and run Rooster. We will see that the data is going to be in descending order as seen in our output terminal here. We also have the option to use a lambda function. Let's show that here. And this lambda function is going to be comparing using the less than operator. So this is also going to order in ascending order. Let's pass this through the compiler. The build is good, so we can clear and run Rooster. And this is the data we see here that we expect. And the last thing I am going to show you is that it is possible to even sort collections containing custom items. Here we have an std vector containing book objects, and these are going to be sorted based on the less than operator that we have in our book type. Let's come down and comment out the line that uses lambda functions here, because we want to run the code that uses the default predicate without explicitly specifying our own predicate. Let's make sure our comment here is visible because I don't want this to be confusing. Then we're going to enable this line, which is going to sort these books using the less than operator that we have in our book type. If we go up, we're going to see that we have a less than operator. So this is going to be used to decide which element is greater than another in this sorting algorithm. We can pass this through the compiler. The build is good, so we can clear and run Rooster, and we will see that our books will be ordered. We have one in 1734, 2000, and 1995. So what is being used here? Let's go back to our less than operator. I was looking at unsorted data. If we go down, we're going to find 1734, 1995, and 2000, and our less than operator is used to decide which element is greater than another, and books are going to be compared based on the year member variable here. Hopefully you can see this. Let's go down and use an explicit predicate. We can go down here, comment out this line, and use std less. And this is going to do the same thing, only now we are explicitly specifying the std less predicate to be used. We can pass this through our compiler. The build is good, so we can clear and run Rooster, and we will see that our data is going to be ordered 1734, 1995, and 2000. So we are ordering in ascending order. We can also try out another predicate, which is going to be our std greater functor here. Let's try and build this. and we're going to pass this through our GCC compiler. The build is good, but we see that we have a comment that this is going to look for the greater than operator. And I want you to see this. I thought the compiler would be able to figure out the greater than operator using the less than operator, but compilers may not be that smart. Let's comment this out and see if this is actually the case, if the compiler is going to figure out this operator on its own. We are going to pass this through the compiler and see what we get. And this is going to throw a compiler error, and the compiler doesn't know how to compare using our less than operator, which is a shame. But this is something that has been already fixed in C++20 using three-way comparison operators. I just want you to be aware of these things if you happen to use legacy comparison operators like less than and greater than here. But we're going to make our compiler happy by providing a greater than operator. And if we try to build, we're going to see that that's going to work now. The build is going to be good, so we can clear and run Rooster, and our data is going to be ordered in descending order. So we have 2000, we have 1995, we have 1734. This is really cool. We can go down and see if we have nothing else to look at. And what I am going to show you now is how to use the lambda function predicate that we have here. Again, this is going to be doing the same thing we did in our less than operators, but we are going to be doing this through a lambda function, which is going to compare both objects here. Now that this is in place, we can use our sorting algorithm with our CMP predicate here, and this is going to order things in ascending order. Let's pass this through the compiler. The build is good, so let's clear and run Rooster, and this is going to order things in ascending order. We have 1734, 1995, and 2000. This is working exactly as we want. This is really all I had to share in this lecture, showing you different ways you can work with your sorting algorithm. If you want more information, you can come back to the documentation and learn all you can about this algorithm. We have our sorting algorithm here. You know that it needs random access iterators. If our container doesn't support these random access iterators, our code is going to blow up. And if you go down, you're going to find a bunch of examples you can play with to really have a strong basis on using this algorithm here. We are going to stop here in this lecture. In the next one, I am going to tell you about the std transform algorithm. Go ahead and finish up here and meet me there.